It's about time I made myself useful again. Unity Connection Approval. If you went to Unity's Netcode page and couldn't understand this chicken scratch, then worry not, I'll help you. If you're like me, then you probably got hung up on this payload part. What is a payload? Where do I define the payload? Where do I send the payload? How do I send the payload? Is this payload encrypted? Should I encrypt the payload? How do I encrypt the payload? I'm going to answer all these questions for you so we can all get back to making games. A payload is a string encoded as bytes. On Unity's webpage, they use ASCII encoding, but I use UTF-8 encoding. Does it make any difference what encoding you use? To me, no. I can't even remember why I use UTF-8 over ASCII, but I probably ran into some issue that I can't remember. The only thing that matters is that it works. Nobody cares, as long as it works. So now you need to define your payload. There are two criteria I want to check in the user's payload. Does the client password supplied match the server host password? I don't want randoms joining my server, so I'll password protect it. Are they banned? I have a unique user ID system that I've created so that the server host can control who is and isn't allowed on their server. I'm not going to go into details on how to make a UUID system in this video. Just know that the UUID is randomly generated and stored on the local computer, then passed to the server as a payload parameter. Later, I'll convert this to use the player's Steam ID. Palworld did this. It's a smart thing to do, since players can't change their Steam IDs. I generally format the payload data a little like JSON in my brain. I start the payload with a curly bracket, and end the payload with a curly bracket. If you're tackling file encryption, this is an easy way to check if the encryption was successful. Did the payload string received start and end with a curly bracket? If it did, then the encryption was successful. I use a comma to separate the payload parameters. The first parameter is supplied by the TextMesh Pro input field. The second parameter is the client's UUID. Where do I define the payload? I'll give you a quick workflow on how to use the payload. Step 1. Define the payload. Step 2. Encrypt the payload. Optional, but highly recommended. Step 3. Convert the payload to bytes. Step 4. Set payload value in the network config. And Step 5. Connect to the server. Step 1. You define your payload first, before the user connects to the server. That is, before the start method client is called on the network manager. On my game, players connect using this connect button, which calls the connect method on the main menu script. You can do whatever you want. Step 2. Encrypt your payload if you're doing that. I use Vikas Gupta's encryption method since I'm lazy and don't feel like learning cybersecurity. If you follow this method, you will find that the encryption keys you generate for it from other websites don't work. The encryption keys are just too big. So I made a byte calculator with an input field and started deleting characters from the generated encryption key until the byte length was sufficient for the 256-bit encryption. Divide by 8, and 32 bytes is the magic number our encryption key needs to be. The encryption IV is exactly half the size of the encryption key, so that one needs to be 16 bytes. If you're lazy and want to use my byte calculator, it'll be in my YouTube Stuff GitHub page, link in the description. Step 3. Convert to UTF-8. Highly recommend you convert to UTF-8 if you're encrypting your data. Don't want your code to blow up because you've decided to use ASCII with the UTF-8 encryption method. Step 4. Set payload value in the network config. The payload is supplied to the network manager using this line of code. Step 5. Connect to your server. Run your client method and pray. Okay, so we defined our payload and sent it to the server. Now what? I'll give you a quick workflow for receiving the payload. Step 1. Add a listener event. Step 2. Server host bypasses the approval logic. Step 3. Convert the received byte payload back into a string. Step 4. Perform decryption. Step 5. Clean up the payload string. And Step 6. Read the payload. Step 1. Add a listener event. In whatever script is handling your network connection callbacks, add a listener event for the connection approval callback and assign it a function to handle the event. My function is named approval check because that makes sense. Supply two parameters, the connection approval request, that is, the payload, and the connection approval response. If the client fails, the response will be set in the joining client's network manager. OnClient disconnected will be called, and here you can display to the joining player why the connection failed. Step 2. Server host bypasses approval logic. Okay, since I don't want to break my game, I'm going to skip all the approval logic if the joining client is the client server. If you ban yourself and try to join the server, your game will break. Trust me. Step 3. Convert the received byte payload back into a string. Create a string called received payload and use the UTF-8 encoding method to encode the bytes back into a string. Step 4. Perform decryption. This is optional, but highly recommended. If you're having trouble, maybe try getting the payload to the server first before bothering with encryption. Once all the logic works unencrypted, then move on to encryption. For encryption, just create an encryptor and supply it an encryption key and an encryption IB. The clients and hosts need to be using the same key. If the encryption was successful and you formatted your payload accordingly, then the payload should start and end with open and closed curly braces. If your encryption key or IV is the wrong size, you will get this error and your game will be broken. Step 5. Clean up the payload string. Remove these curly brackets, split the string down the middle. The left half is the server password, the right half is the joining player's UUID. Step 6. Read the payload. If the server password is wrong, banish them to the Underworld. If their UUID is registered in the ban list, banish them to the Netherrealm. You can add one more check here to control the number of players. If the number of connected clients is greater than some arbitrary limitation that you have set for your game, reject the player. I didn't bother with this yet, but I'll probably add a drop-down so the host can control how many players their server can handle. And there you have it, Netcode connection approval in a nutshell. Be sure to leave a like if you found this video helpful. If there are other topics you'd like me to cover, let me know in the comments. Later!